Hey everyone, welcome back, and today let's solve Leetcode problem 2461 titled Maximum Sum of Distinct Subarrays with Length k. So we're given an integer array nums and an integer k, and we need to find the maximum subarray sum of all of the subarrays of nums that meet the following criteria. So the length of the subarray must be equal to k, which is another input parameter that we're given, and all of the elements of the subarray must be distinct. It must be a distinct subarray. We need to return the maximum subarray sum of all of the subarrays that meet the following conditions. And if no subarray meets the conditions, we need to return 0. And it tells us, if you guys aren't aware, a subarray is a contiguous non-empty sequence of elements, again, adjacent indices within an array. So, in example 1, we have an input array nums to be 1542999 and our k to be 3. This just tells us that we need to find all of the subarrays of length k, or in this case of length 3, and we need to maximize the sum if they have solely distinct elements, if that current subarray that we're looking at has distinct elements. So, these subarrays of nums with length 3 or with length k are going to be 154. That all those elements are distinct, and the sum of that is 10. So that's our current running maximum sum. Then we have 542. Yes, it passes the test. It is still completely distinct, and it has a sum of 11. So our current running sum max is now 11. 429 still passes. Yes, we have all distinct elements. Now we're at 15 as the maximum current sum. That's going to be maximized. And we have 299. Not all of those are distinct. 9 is actually repeated, and so we don't take this into consideration for its sum. And same thing applies to 999. And the maximum running total that we had for any subarray that met the requirement to be distinct was 15. And so we return or output a value of 15. So in example 2, we have our input array nums to be 444 and our k to be 3. There's only one array, or rather one subarray of the input array nums with length k or length 3. That is the whole input array num itself, but it is not distinct. It has 4 repeated twice, and so we simply output 0 as our kind of base case where we don't actually have any subarrays that meet the following criteria. So with that out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so what would kind of be a smart way to approach this? It doesn't necessarily have to be the most optimal, but what is kind of a good way, based on the algorithms that we've learned so far, to actually solve this problem, I guess, somewhat efficiently? Well, we know that we need to look for all of the subarrays that are length k. And when we know that we have a fixed or constant length for all the subarrays that we're looking at, we can have or use our fixed, oops, I don't know why I have caps lock on, fixed sliding window algorithm, where we simply just increment or shift our left and rightmost pointers from the current subarray by 1 at each iteration while it's still in bounds, and check for its sum to maximize our current total, which we ultimately return. However, this would actually give us a TLE if we tried to implement that solution. I will actually show it to you guys in this video. Feel free to just try it out yourselves if you guys want with the fixed sliding window algorithm. You're just initializing 2 left and rightmost pointers for each subarray for the current window, L and R, or whatever you like to call it. I just call it L and R for easy access. But what is a more kind of faster way to solve this? Well, we can still use our sliding window algorithm, but instead we're going to have a dynamic range, right, from the start index to the end index that's actually within the array that we basically adjust based on these problem constraints, based on the number of indices and values we have or counts of have, and if the current sum and length is equal to k or not. A little bit more optimal approach, right? And the way we're going to do this, let me actually comment this out, is instead have a dictionary. And I guess technically this isn't the brute force solution, I would guess. I guess the brute force solution would be more like nested loops, just go through every single subarray and check like that. This technically is kind of like a smarter way than the brute force solution, so I'm just going to call it brute force, but technically brute force is nested loops to actually find all the subarrays manually like that in our input array nums of an n squared operation. But this is also a pretty slow kind of algorithm for this problem, at least, right? So we're going to have a dictionary, and it's going to basically track the frequency But what is it going to track the frequency of? Where we have to actually keep track of the occurrences of all the elements in our current window to make sure they actually are distinct from one another and they have a length that is going to be equal to k. So we're going to track the frequency of all elements in the current window. Okay, I think that should be right. In the current window to ensure that they are all distinct, right? Because that's what the problem statement literally tells us. We want to make sure that every single current window or subarray is distinct. It doesn't have any repeated elements, right? So a quick high-level rundown of the variables that we're going to use. I'm going to have a current sum that just tracks the current running sum of the current window that we're building up, and we're going to have a max sum, which is going to be what we return, right, which is going to store that actual max sum within all the different k distinct elements or windows that we actually build up and encounter in these iterations of our infinite array nums, and we'll have a start index to actually mark the left boundary or the leftmost indice of the sliding window kind of subarray. So with that out of the way, let's go ahead and dive straight into the code here. So I'm going to have my num count initialized here, right, like we talked about just now, the actual hash map to store the frequency of all the different elements in the current window. So I'm going to call it num count, and it's going to be initialized to a default dict, just to kind of handle cases where we don't actually have, okay, I don't know why I spelled this wrong, default dict, and default dictionaries are pretty helpful in Python, especially when you don't want to have, especially when you don't really necessarily have keys already in your dictionary and you just want to assume that they're there or have a default value of 0. And I don't know why. I think that's how you spell it. Default dict. Yeah, I think that should be right. And for our kind of integer, or rather, sorry, a data type within this dictionary, we're going to have a type int. Okay? So that's going to be a default dictionary, simply going to, again, keep track of all the different frequencies of all the different elements in our current window that we're building up to check if it's actually distinct, and it has a length of k. And again, I don't know if that's how you spell default. I think that should be fine. We'll go back to that when we need to. Anyways, so now let's actually initialize the three important variables that we need to keep track of: the current sum, the maximum sum that we return, and the actual starting index, the leftmost boundary of the current window. So I'm going to have a start to be 0. I'm going to have a current sum for the current window sum to be equal to 0 as well, because of course we haven't actually built any subarrays yet. We haven't traversed through the infinite array nums yet. I'm going to have a max sum, the final max sum that we return, which is going to be the maximum sum of all the distinct subarrays with that length k. Okay, so a quick reiteration of what these means. The current sum, as we see right here, is going to store the sum of the current window. The starting index is simply going to be the leftmost boundary or index of the sliding window algorithm, and the max sum is going to just keep track of the largest sum that we actually meet within all the different distinct subarrays or windows that have a length of k. Right, which is going to actually help us manage and actually easily, efficiently kind of evaluate that sliding windows algorithms and their properties. So now let's actually instantiate or begin the for loop to start our sliding window algorithm. So I'm gonna start with a standard for loop here for end, for our ending index to actually build up our sliding window in the range of the length of our infinite array nums. Pretty standard for loop here, just iterating through all the different indices of our input array nums, right, where end is going to iterate over the indices of the array, right? And what exactly is end? Well, end is simply going to be the rightmost boundary of the current window, and that's going to be expanding by one index, that is, with each iteration in this for loop, right? That's why for loop is pretty helpful for sliding window algorithms similar to this one, right? It's simply going to expand one as the rightmost boundary for the current window in each iteration. Now, once we see this current element, nums at r, or rather nums at end, we want to increment that occurrence in our default dict, right? We don't even have to check if it's in the default dict itself because it is a default dictionary. Even if it's not, it has a default value of 0, and so we can simply increment its count by 1. So we'll say num count at the index nums at end, whatever value that is at that index end, is going to be incremented its occurrence by 1, right? We're simply incrementing the count of that index, or rather element, nums at that index end in the num count dictionary by 1, right? To just make sure we accurately keep track of the occurrence of the current number at that index end and store that updated value or frequency in that hash map in this current iteration. And then we have to actually add that value to our current sums, or rather to our current Windows sum. So current sum plus equals nums at that index end. Technically, I should have called this current Windows sum, but I feel like that's too long of a name and I don't want to keep accessing current Windows sum like that, so I'm just going to say current sum. I think it's a little bit easier to type out manually, right? We're simply adding it to the current sum and updating the sum of that current sliding window that we're actually building up and checking if it actually has a length of k and it's distinct. Okay, so now that we've actually added to our current window's sum the index or element that we're at right now, now we have to actually enter a loop, right? We have to actually check, well, while num count, again, recall that that's our hash map that stores the frequency of all the different elements at nums at end, right? Nums at index n for this current index. While that has a frequency that's greater than 1, or end minus start minus, or rather, sorry, plus 1, or if that's greater than k, and I'll explain this in a second, then we simply have to num count at nums at start, at that index, minus equals 1. Just update our leftmost boundary by 1. Now, just to reiterate what this actually does, well, this while loop simply checks two different elements. It checks if any element in the window actually occurs more than one time. So if nums at count at nums at end, while that's still greater than 1, the element that we just added to our current window, while it has a count greater than 1, so while it's repeated, it's not distinct, or n minus start plus 1 minus k, the length of our current window, which can be found using the difference between the ending and the starting index plus 1 for that 0 index overcount, while it has a current window size or length that's greater than k, well, we need to shift our window left, right? We need to decrease the window's size by either decreasing the frequency of the overcounted element that's repeated, or decreasing the overall length of the subarray because it's already greater than k. And so we want to just shift our left pointer by 1, or our start leftmost index by 1 in our current window by simply just minus equaling 1, right? Just decrementing its frequency in our hash map by 1, because we have to see it one less time and move to the right? So if the size of the window again exceeds k, or any element's frequency, in this case nums at end, the element that we just added, while that has a frequency greater than 1 in our current window, we have to just move 1 to the left by simply first subtracting nums at start from the hash map and then actually moving 1 to the left, right? We just decrease the count of the element at the index start to remove this element from the sliding window and decrease its length to move 1 to the right. Okay, so now that we've done that, now we have to check, well, if num count, again, this is the hash map, at nums at start, I think it's nums, yeah, at nums at the index start, well, if that's equal to 0, then we need to make sure to delete it completely from our actual hash map, right? We don't actually have any occurrences of that actual element anymore, so we have to delete it. So we'll say we will use the del keyword in Python from our num count hash map, nums at start, right? The key nums at start, and we're deleting that from our num count hash map. We're just deleting from num count hash map nums at start key, whatever value that is at that starting index, right? If the count of this actual index nums at start, or value at that start index, if it actually becomes 0, right? If it actually becomes 0, then we need to delete it from nums count to actually keep our dictionary clean by removing all the keys that again have that 0 frequency. Now, once we've done that, now we can actually current sum minus equals nums at start, and then actually increment our start by 1. Right? What are we doing here? We're simply reducing the current sum for our current window by nums at start, because we're excluding it from our current window by removing its frequency by 1, or decreasing its frequency by 1, and then shifting 1 to the right because we already have an overcount of repeated letters, or our current window length is greater than k, and we have to actually move our starting index 1 to the right. Right, we have to actually shift it to the right so we actually can kind of proceed to change or modify and decrease the length of our current window, right? Just actually maintain a valid sliding window while one of these conditions are actually true. So while we have an invalid window, right? Okay, so once we've done that, now we have to check, well, if end minus start plus 1, well, if that's actually equal to k, so if the length of our current window is actually equal to k, we can say max sum is equal to the maximum of course, itself, because we don't want to make it smaller, and the current sum for this current window, right? The current window that we've actually built. So again, if the window size that we're currently looking at or building up is actually k, and it meets all these criteria while none of these conditions are true, then we can update our max sum variable that we ultimately return to be the maximum of itself, or the current sum, whatever is larger, right? And this makes sure that only the valid subarrays that are distinct of that length k are actually considered to actually update our maximum sum with. Otherwise, we don't have to actually enter this conditional, and we don't have to update our max sum. And effectively, we simply have to return our max sum. Why? Because it would have eventually stored the maximum sum for any sum of any valid window of length k that meets this criteria, that actually has a length of k, and that does not have any repeating elements. Because again, if it has any repeating elements, it is not efficient. And I just realized this all should be indented within the while loop. I don't know why I did it like that. This all should be, and then this should not be in the conditional. Sorry about that, guys. Just realized that I just kept typing, didn't actually check where I was indenting or not. That's one issue with Python. Got to get used to it. But as you can see, if I were to submit this, unless I made any syntax errors here, this should be accepted. Okay, let's see what I did wrong here. Okay, this should be num count. I don't know why I have an S, extra S there. I did it one here as well. Sorry about that. Now this should work. Sorry about that. And as you can see, this is just about as efficient as you can get. So a quick error that I actually made was I didn't include this in our while loop as well. So even though one of these conditions could still be false, I still went on out of this while loop to work on this. When in reality, I have to actually update my window and actually increment start by 1 in this while loop, because otherwise I wouldn't actually do anything and actually update our current sum and window in the while loop. And so these conditions would always be false, which we don't want. We want none of them to be true, right? So they'd always be true, rather, sorry. If we don't actually put this in the while loop, we have to actually manually change and update or rather decrease our window size and sum within this while loop while one of these conditions are actually true, while one of these conditions actually make our window invalid. And once it's not invalid, so once both of these conditions are false, then we can exit the while loop and enter this conditional, check if the current window is equal to k, and increment our max sum accordingly. And effectively just return that max sum outside of this for loop once we're done iterating through all the different elements, or rather ending indices in our input array nums. So a quick kind of reiteration, how did this code kind of work as a whole? I'll try to be as fast as possible because this video is kind of getting long. So we're simply just dynamically adjusting our sliding window using our starting, again, leftmost index, and our ending rightmost index to actually explore all the different subarrays of size k that are valid that we can maintain and check using this while loop, actually incrementing our window to the right using our left pointer, right? And by maintaining this dictionary of frequencies of all the different elements in the current window, we can make sure that these subarrays are actually all distinct. They actually all have elements that are distinct values that we check right here, while the frequency of any element that we actually just added is at least 1. Okay, or rather, at most 1, right? And we simply have to calculate the sum of these valid subarrays if they actually have a length of k and they're valid, which is determined by this while loop once it's done, and update our max sum accordingly when the window size equals k to the maximum of course, itself, because we don't want to make it smaller, and the current sum for the current window that we just built up. So, for the time complexity of this solution, this is going to be a big O of n iteration, or rather, time complexity, it's a linear time solution. Why? Because, of course, the n pointer is going to iterate over our input array once for every single index, and the start pointer is only going to move when the window actually becomes invalid. And since each element is really only processed at most, I guess, twice with the start and end, it's going to be simplified to big O of n. Technically, it's big O of 2 times n, but coefficients, again, do not matter in space and time complexity. So this is going to have a simplified time complexity of big O of n, or a linear time solution. And for the space complexity, this is going to be a big O of k solution. Why? Because, again, really the only extra data structure or auxiliary memory that we're using is this num count hash map, and it's going to, at most, store all k elements in our input array nums. Okay, so that's going to be it for this video. If you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.